All right, the next topic are lasers and how they deal with diffraction and interference to give us the modern phenomenon called holograms. Okay, so first we need to understand the difference between coherent and incoherent light. So white light is a form of incoherent light. You have all different wavelengths, all different frequencies, all different colors of light, all mishmashed together. The result being an incoherent perception of the color, which is really a color of white light. Now, if we take a red filter and put it in front of this white light, then we will get red light, but it will still be incoherent. They'll be in phase, out of phase, but it's still monochromatic. It's still one color, but it's incoherent red light. Um, but with laser light, you get waves that are in phase with each other and they're the same color. So this is what coherent light is. Now, the word laser is kind of like the word scuba. It's an acronym or an acrostic. SCUBA stands for self-contained underwater breathing apparatus. Laser stands for light amplification by stimulated emission of radiation. So the way it works in short is that inside of the laser they can stimulate the electrons simultaneously such that they produce not only the same color but the same color in phase with each other. So you get a very intense, because of constructive interference, you get a very intense monochromatic coherent beam of light that can do rather strange things. So one of the strange things that laser light can do is that they can produce holograms. So the way a hologram is made is they take a laser beam, they shine it through a lens onto a mirror, um, and onto an object that they want the hologram of. So you have laser light coming from the mirror to the photographic plate, the holographic plate, but then you're also having light that is reflecting off the object onto the holographic plate. And then this portion is where there's interference patterns occurring between the coherent light directly off of the mirror and off of the object. And then you end up with diffraction and interference striking the photographic plate, such that you not only get an image, but you get a three-dimensional image. Okay, so here's another um, setup. So the beam that goes directly onto the film is called the reference beam. So in this case, it would be from the mirror. Okay, and then the beam that actually reflects off of the object is called the object beam. And then here's the diffraction pattern and interference pattern onto the film. Okay, so here's the setup, and here is how you view a hologram. So you need a reconstruction beam. Ideally, it would be the same laser beam that took the image to begin with. You get the clearest hologram if that's the case. This is actually what a close-up of a holographic plate looks like. And if you shine a reconstruction beam at an angle, you produce the virtual image here, and then the viewer is here, and they'd be looking through the film and see the hologram. Actually, it's not through the film, but they're standing here. So it's kind of like where you are when you see a rainbow versus where you are when you see a hologram. So you're here and the hologram's here. So here's an actual setup. You can't actually see the laser beam. It's drawn in with special effects. But here's the reference beam. It's shown off of a mirror directly onto the holographic plate. And then here it's shown on this object, which then reflects it onto the holographic plate. So they're taking a hologram of a skull, and then here's what the skull looks like let's go three-dimensional. Okay. So holograms. To construct the image, a laser of the same phase is needed for optical image quality. The hologram is a sort of high-tech, super sophisticated diffraction grating. So what you see here is similar in kind to just a simple diffraction grating, which is a bunch of just straight lines. But this is not straight lines, it's lines that give the net effect of this object due to the interference pattern and diffraction pattern that occurs when the reference beam and the object beam interfere with each other. Okay, so that's in a nutshell how holograms are produced.